Semantic search goes beyond traditional keyword-based search methods by understanding the intent and contextual meaning of your search query. I'm going to show you how to incorporate semantic search into your Java Spring Boot application using MongoDB's vectorSearch. I'm Tim, and what we're going to be building today is a semantic search engine that will allow you to search for movies based on plot descriptions. So we're going to need to set up a couple things for this. First, we're going to set up our MongoDB database, then we're going to get our API key for OpenAI, and after that, we're going to build our Spring Boot application using Spring Initializer. First things first, we're going to create a new project, so I'm just going to call this one Movie Semantic Search. What we're going to do is we're going to start with a blank project and we're going to create a deployment. So for this, we're able to accept the free tier because this will have everything we need, and the rest I'm just going to take as defaults. Once it's created, you're going to create your own username and password. I'm able to take the defaults, but just make sure that whatever you take down, you remember you're going to need this when you're accessing from your API. Once we have this, first thing we're going to do is we're going to load our sample data. So MongoDB provides a sample dataset, and in this dataset there's embedded movies. What this does is it contains a bunch of movie information that has the plot descriptions embedded. I'm going to explain a little bit about that in a minute, but for now we'll just wait for this to load. Now that our dataset is deployed, we're going to go into our collection and have a look what it looks like. So if we choose our sample mflix database, the embedded movies collection, and we're just going to have a look at one of these documents, there's a particular field that's important to us. So if we scroll all the way down, you'll see the plot embedding array. This is an array of floating point numbers. What these are a representation of the similarity of our data in an nth dimensional space. Now, data that is less similar is further apart, data that's more similar, closer together, and you'll see that for our particular example, it's 1536 dimensions. Now, depending on what model you use to embed the data, it will be a different sized array. It's important to take note of that because you'll need that when setting up your search index. That being said, our next step will be to set up the search index. So if we pop up here, we go into Atlas Search, we're going to create our search index. Now what we're going to do is we're going to set up an Atlas vector search index, so JSON editor. Next, we're going to choose our collection from earlier. So this is sample mflix embedded movies. Now there's a couple of things that we need to set up. So first is type vector, that's fine to leave alone. Now the path, so this is our field name. So this is our array that I was showing you earlier, plot embedding. The number of dimensions, like I said earlier, it was 1536, and the similarity. So this is just how it calculates how close they are in that space. So you'll see here it gives an explanation of the different methods it has available. What we're going to do is we're just going to use Euclidean. Depending on what data you're using and what your application is, you may want to use one of the other ones, but you can find out more about that in the MongoDB docs. Perfect. Now, you can keep it as the default name. You will need this when you're accessing it later from your aggregation pipeline in your application. We're just going to leave it at that, vector_index, and next. Once everything looks good, we're going to scroll down and we'll just create search index. And we're all set. This will take a moment to set up. MongoDB will let you know when it's been created. Now that that's set up, we're ready to use it. First thing though, before we go to our application, we're going to need to set up our OpenAI API key. So if we pop over, we're going to go into API keys and we're going to create a new secret key. So we'll need this later when we're accessing from our application, Java plot search, and we create our secret key. Now, this key will no longer be there when you're building it, so make your own, but make sure you copy that as you won't be able to access it again. Now we have everything we need from OpenAI. We're done with that. Last thing to do is to set up our actual Spring Boot application. So if we pop over to Spring Initializer, there's a couple things you need to set up here. So first is our project. Now this can be built using Gradle, but for this tutorial I'm using Maven, so that's selected. Again, language is Java. Choose your Spring Boot version and we're just going to give it a name. Java Vector Search. Perfect. We're going to package it as a jar and choose your Java version. I'm running Java 17. Now we just need to add our dependencies. So there's two we'll need. First, we're going to need to use the Spring Reactive Web. So we're building the reactive application, so make sure you don't choose Spring Web. And because we're using reactive, we're going to have to use the MongoDB reactive dependency as well. This is everything you need. So once you have that, you're just going to click generate, and you can open that up in your IDE of choice. Now, let's get going. Now that you have your project open in your IDE, first thing we're going to need to do is we need to go to the pom.xml file. So in the properties section, we're going to need to specify our MongoDB version. The version I'm going to use is MongoDB 4.11.0. Now, the reason for this is because Spring Boot may be using a previous version of the MongoDB driver. What this will mean is we won't be able to use some of the vectorSearch specific properties, and we'll need those when we're making our aggregation calls later. Feel free to use a more up-to-date version of the driver, but this is the most up-to-date one for me that I know has all the features I need. Now that we have our pom.xml file configured properly, what we're going to do is we're going to set up our plain old Java objects, our POJs. So if you pop over here to our source main Java, we're going to create a new package, and we're going to call this one models. And this is where we're going to have our POJ. So the data we're going to handle are documents from the sample data that you just loaded into the cluster. For each document and subdocument, we need a separate POJO. MongoDB documents look very similar to POJOs already, so it's very straightforward to set up using the MongoDB driver. Now, if we go here, we're going to create new, we're going to create our class, and we'll just call this movie. Now, what this will do is we're going to set up a couple of different fields. So first, we're going to start with @bson property, and I'll explain what this is for in a second. And we're going to call this private object ID. Now, we need to import a couple of things first. So what this does is it just assigns the bson property, so the property in our database will be _ID, so that's our ID field, and in our actual application, it's going to go by ID. This is just so we don't break any naming conventions in Java. Now, there are a couple of fields to set up here, but it will correspond to all of the fields in your document already in your database. So you can use that for reference and you can follow along, but I'll catch you up once I have everything followed up here. Now, of all the fields, you'll see there's still a couple of red squiggly lines. So that's IMDb and tomatoes. That's because we haven't created these models yet. So like I was saying, we need a separate POJO for each separate subdocument. So we're going to go back here and we're going to create our models. So we go back class, and what we'll do is we'll start with IMDb. Perfect. This one's a little bit shorter. So private double rating, private int votes, and of course we're going to add semicolons because we're doing Java and not Python, and then private int ID. This isn't an actual document ID, this is a separate ID in our subdocument, so we don't need to use the bson property here again. And again, so once that's done, now we still have a couple more, so we have tomatoes will be next. So new class tomatoes. And for tomatoes, it's just two more. So this is our private viewer, and our private date last updated. Now we need to import our date from Java util, and we need to create our viewer. So new, this should be our last one. Private double rating, private int num reviews. Perfect. Now, what you're going to need to do is you're going to need to set your getters and setters for all of these. So I'm using Eclipse, so I can just pop up to source, generate getters and setters, and I'm just going to do this for all of my new objects. Now, and I'll call back when I'm done. Now that we have our getters and setters set up, we're done with our POJOs that we need for our application. What we're going to do is we're going to set up our connection with our MongoDB database. So if we pop over to source, main resources, and application properties. So we're going to need two things. We're going to need our connection URI, and we're going to need our database name. So if we type in these mongodb.uri and our mongodb.database. Yeah, perfect. This will just be how we access it later. Now for our connection string, what we're going to do is we're going to go back to our database over here. If we pop over to database, overview, perfect. And we're just going to hit connect drivers. We're doing ours in Java. And this is our connection string here. So we can copy that. Now the other thing you're going to need is you're going to need your password that you set up earlier. So if we close that and we pop back to our application, pop that in there. Now my password will be different to yours. I hope yours is slightly more secure. And remember that this will be shut down by the time you're following this tutorial. And again, for a MongoDB database, so this is the database we were using earlier. If you're following along with this, it's called sample_mflix, or the name of the collection that you're trying to access yourself. So perfect, we can save that, and what we're going to do now is we're going to set up a configuration file. So you can just pop this anywhere here in the application. I'm just going to pop it here, and we're going to go new, class, and we're just going to call this MongoDB config. Now, there's a couple things we need to set up first. First, we need to denote to Spring that this is a configuration class. So just at configuration at the top, and we need to import this from Spring. So yeah, that's just to denote to our application that we're setting up a configuration class right now. Now we're going to need to import those values that we set in our application properties. So at value, and then this one is our MongoDB URI. Perfect. And then we'll just call this private string MongoDB underscore URI. Now import our value, and we're going to do the same for our database. At value MongoDB dot database, and we'll call this private string MongoDB underscore database. Now that we have our values imported, we're going to set up our Mongo client. So if we go at bean, we'll just call this public Mongo client, and then Mongo client. And we need to import a couple of these. So we'll import bean from Spring and Mongo client from our reactive streams. Now in here, we're going to set up our codec registry. So what our codec will do is it will allow us to convert from our BSON that we use in our MongoDB database to our POJOs that we're using in our application. To do this, we'll use a codec. The default codec we use is capable of handling most Java data types, so this will be our doubles, ints, and it will be able to convert them back and forth so we can work with our data in our application. There's a couple of steps to this. So first we'll do codec registry and POJO codec registry, we'll just call it that, equals codec registries dot from registries. And there's a little bit that needs to go in here. So first, before we do anything, we'll import codec registries. Now we'll go for our Mongo client settings and we'll configure this. So Mongo client settings dot get default, and we'll just get the default codec registry because this will be able to handle most of our data types that we need anyway. Depending on your application, you may need to use a different codec, but this will cover you for most cases. Mongo client settings, and we'll import that from MongoDB, and then codec registries dot from providers, and again we'll give ourselves a line break just so we can make this a little bit easier to follow, and we'll just call this POJO codec provider dot builder, and then we'll just set this to dot automatic true. Perfect. And then just dot build. That should be everything we need from our codec. Once our codec is set up, we just need to set up our Mongo client settings. So below this, what this means is we'll just go Mongo client settings equals Mongo client settings dot builder, and we're going to need to apply a few things here. So we'll give it our connection string that we have our MongoDB URI, and we'll give it our codec, and then we'll just set it to build. So again, we'll just give some line breaks to make it a little bit more readable. Dot apply connection string. What we'll do here is we'll create a new connection string, and this will be our MongoDB URI. Now we need to import this from MongoDB, and it's going to be very angry because we haven't closed everything yet. But then we'll set up our codec registry and perfect our POJO registry. And finally, we just need to set up .build. Now that's everything we need from our Mongo client settings. So what we'll just do now is we'll return. So if we pop down here and we return our client, Mongo clients, first we need to create with the configuration we've given it there. So that's just our settings. If we give this a lowercase l, and of course import from our reactive. So that's everything we need from our Mongo client. Lastly, what we need to do is we just need to get our database. So at bean, and we're going to set public and get our Mongo database. And we'll just call that Mongo database. We need to use our client for this, and then we'll just return our client with our database. Perfect. And we use our MongoDB database that we have in our applications properties. Now we just need to import this from our reactive. Perfect. And this is everything from our MongoDB config. So if you're used to using Spring with MongoDB using their integration, you're probably used to having this abstracted away. What this will do is it will allow us to access our client directly, and we're going to need this when we're taking advantage of some of those aggregation pipeline features that we need for vectorSearch that aren't supported by Spring yet. So in our database, we already have the embedded plots, but what we're going to need to do is we're going to need to embed the user's prompts so we can match their similarities against those plots to find what they're looking for. So to do this, what we're going to do is we're going to send our user prompts over to the OpenAI API to be embedded, and we're going to use those to query using our vector search against the data in our database, and we'll measure the similarity between those to find the most related content. So first thing we need to do is we need to use that key we got earlier from OpenAI. We're going to go to application properties. We'll just call this openai.api.key equals, and then whatever your key is. Again, create your own. This will not be there when you're following this tutorial at home. And now we need to set up a service to interact with it, with our AI API. If we go over to our packages, we're going to create a new one. So I'm just going to get a new package, and we'll just call this one services. So in here, if we create our OpenAI service, so just a new class, OpenAI and service, perfect. And there's going to be a couple steps here. So first we're going to need the actual OpenAI API URL. So if we call it, this is going to be a constant, so we can set this up here at the start, private static final, and then string, and this is OpenAI underscore API underscore URL. So you're able to find this in the OpenAI documentation. So I'm just going to copy it here. And next we need to get our key. So this is just going to be at value again, as we're going to be taking it from our application properties. And what we called this was OpenAI.api.key. And what we're just going to do is we will call this private string OpenAI. And again, we can give it OpenAI underscore API underscore key. And we'll need to import our value to this class as well, just from Spring. Perfect. Now, we'll also need to set up our web client. So if we go private web client, we'll just call this web client, keep it simple. And we'll need to import web client, just from Spring as well. And this is how we're going to interact with OpenAI's API. So first thing we need to do is we need to set up a post construct. So this just means when our application is created, it will run this post construct void init. And what this function will do is it will run when our application is initialized. So this dot web client equals, and we'll go to web client builder. And there's going to be a couple things we need for this. So we need our reactor connector. We need our URL. So that's our OpenAI API URL. And we need to set a couple of headers. So first things first, we'll start with the client connector. So if we just go into new line here, client connector, and we'll set this to new reactor client HTTP and then connector. Perfect. And we need to import this from our Spring Reactive framework. Now we need to set our base URL, and that's of course going to be our OpenAI API URL, not our key. And we need to set a couple of default headers. So the first we're going to set up is just the content type, and then we'll need our key as well. Default header, and we're going to set content type, and this will be JSON. So media type dot application underscore JSON underscore value. Perfect. Now we need to set another header. So this is going to be default header, and then we're going to set this to authorization bearer, and here we'll just add our OpenAI key. And lastly, we just need to set this to build. One more thing to import. This comes from our Spring framework, and this is everything we need here. So this will just create a web client that we're able to access our OpenAI API from. Next, what we need to do is we need to create our embeddings, and we need to actually post to the web client. So what we'll do is we'll set up our public mono list double, and this will just be our create embedding. What this will do is we'll pass in a string of our text, and now we need to do a couple of imports. So import mono, of course, using reactive, and list. Okay, now there's a couple of configurations that we need to do for our OpenAI API. So first what we'll do is we'll pop down here and we'll go map, this will be string and object, and then we're just going to create we'll call this body, and if we create a map dot of Now in here, we're going to put in the model name. So that's the model they use to embed. Again, like I said earlier, when you're embedding your data in your database, we're using the sample that MongoDB provided us. Make sure to use the same model when you're embedding your queries against it. Just otherwise, the way they're mapped into that space won't match up. Let me go model. Now I'm getting this from the OpenAI API documentation. Depending on what data you're using, you might use a different model, but this is text embedding ADA 002. And then we just need to set the input type, so that is text, or input type, our input, so our data that we're sending in. Now that's everything we need from that. So that's just going to be the body of our message. And now we just need to actually call it using our web client. So return web client dot post. Give ourselves some space to work here and close this bracket that we do not need. Perfect. So in this, we're just going to have to say first our URI. So this is the embedding URI. So again, reference the documentation, but what we're using is just v1 and embeddings. We're going to set our body value to be our body that we just created earlier in that map. We're going to set retrieve and then body to mono. Now here, what I'm going to do is I'm going to set what our response will be. So just what we get back from our API. I'm going to use a class called embedding response. We're going to create that class in a second. So you'll get the IDE giving out to you here, but don't worry, we'll fix that in a moment. So embedding response.class, and then we're just going to have to map this. So map embedding response, and just, again, something we'll set up in a moment. Get embedding. So we have that there, and we are missing a curly brace. Perfect. Now that should say web client, not web client. That should say retrieve, fix that there, body to mono. Again, it's going to give out because embedding response does not exist yet. We'll fix that now. But that should be everything we need in our service class for interacting with the OpenAI service. So what we're going to use that for is taking in the user's text input, sending it to OpenAI, embedding it, getting that back, and then querying our database with that embedding. Okay, now as promised, we're going to set up that embedding response. So if we pop up to models here, and we're going to create a new class. Now we'll actually start with the embedding data. So we'll call this embedding data. And this will be what's returned in terms of when we were looking at our document earlier, you saw that array of floating point numbers, and that's essentially what this is. So if we create private list double, and we'll just call this embedding. Now we'll import list, and we'll generate our getters and setters. That's everything we need from this. Now we just need to go back to that embedding response that we were talking about earlier. So this is what's actually returned from the API. So if we call this one embedding response, this one isn't much longer itself. So it's just private list, and it's just a list of those separate embedding data. So list, and we'll call that embedding data. And we'll just call this data. We import our list. And we go public list double. And then we'll just call this get embedding. And in here, we're just going to return data.get. We'll give it the index 0. And then get embedding. Perfect. So we can actually retrieve our embeddings. Of course, close that off properly. There we go. Now, other than this, we just need to get data and set data. So again, if we pop up to source, generate getters and setters just for our data. And this is everything we need to do in this class as well. So that's perfect. So we're actually able to now send our user's search query, embed that, and now that we've retrieved that data, it's going to be stored in the same way as our data is stored in the database. So next steps is actually to set up our vector search. So we have our database, we're able to embed our data, we're ready to send and receive our movie documents. How do you actually perform the semantic search? So the data access layer of our API implementation takes place in our repository. So if we go up here and we create a new package called repository, or repositories, perfect. And next what we're going to do is we're going to create an interface. So this is just going to be called movie repository. So it's obvious what it's doing. Here we just need to add one method. So this will be our method to actually perform our vector search. So find movies by vector. So if we call this flux movie, find movies by vector, and we're going to go list double, and it's going to take in our embedding that we get back from the OpenAI API, and close that. Perfect. Now we just need to make a couple of imports. So import flux, import movie from our models, and import list. There we go. Now we need to actually implement this repository. Okay, so to add the implementation for this repository, we're just going to go new, we're going to create a class, and this will contain the actual logic. So movie repository, and then implementation, impl. Perfect. So if we create that, we hit implements, and we say movie repository. Perfect. Now it's missing that method. There we go. So we have our find movies by vector. So there's a couple things we're going to do. We're going to actually need our database. So if we start with private final Mongo database and Mongo database, that's perfect there. And we'll just import that from MongoDB. Now we need to set up our constructor just so we have our actual client when it comes in. And this will take in Mongo database that we configured earlier in our config file. And we're going to go this dot Mongo database equals Mongo database. Now, of course, this doesn't need to be a final because we're setting it here, and that should be changed to Mongo database. Perfect. We'll give this the proper case types, so it is all correct. And now what we need to do is we need to get our collection. So what we'll do is we'll use our get movie collection that we have from MongoDB. So we pop our private Mongo collection, as we'll be returning our Mongo collection, returning movie, and get movie collection. In this, what we just need to do is we just need to use MongoDB's methods to actually get our collection. So we'll be using the driver for this. Return Mongo database dot get collection. Now this is our embedded movies collection from our database, and then we're returning type movie. Of course, we need to specify that this is actually movie class. Now a couple of imports. So first import Mongo collection, and we're ready to go. So last step is just to set up our vector search. Now when we're setting up this, there are a couple of different fields that we need to specify. So we need to specify the index name. So that's the index you gave it earlier. We need to specify a number of candidates that it queries against and the limits, the amount of results it gives back. Now, you can find out more about the different configurations you need when you're setting up your own application, but if you're following along with this, all of this will work perfectly fine for you. I'll explain a little bit more as I'm going through it. Okay, so first we're going to have to set a couple of our configuration values. So this is going to be the string. We're going to use the index name, so the name you gave your index in your database. You can check it if you don't remember, but ours is vector underscore index, our number of candidates. So this is just how many other neighbors it will use when it's doing its nearest neighbor search. So when you're deciding this, you will want to have it to be higher than your limit that we'll set in a moment, so the amount of documents you're returning back. Higher numbers will provide better accuracy, but it will also give some latency hits. Of course, you're including more values in the search, so it will be more costly. Equals, and we're going to use 100, and that should be plenty. And then we're going to go int limit, and we'll just return 5 movies, so the 5 most similar movies. Now we actually need to create our pipeline. So for this, what we're going to do is we're going to go list, we're going to go bson, and pipeline. Now, we're just going to go as list, and we're going to create it here. So there's going to be a couple of steps to this. Now, the only thing we're actually including in our pipeline is the vector search. If you're including more, this will be longer, and you're able to refine it to get better value in your application. Aggregation is a massive topic. You are able to use it to leverage your data to the best of its abilities. Definitely recommend learning more about it, but for this, we're just going to stick with vector search. And of course, if you want to learn more about it, pop over to the Developer Center or MongoDB University. We have classes on it. So now that we have our limit, our known candidates, and our index set up, we're going to actually create the pipeline. So that's just list bson, and we're going to go pipeline and equals as list. So when you set this up, there's going to be a couple of red squiggly lines. This will be because it will be trying to create methods based on how the naming here works. It's okay, you can ignore that because we're going to fix those later as we add more to our movie service and add more to our models. So if we go here, we go, first we're going to need to set up and define the fact that it is vector search. So that's vector search. And in here, we're going to have our field path. So that is just the name of the actual field in our embedding. So you saw earlier that was the array of floating point numbers. So ours was plot embedding. So field path. And just give that as a string. So plot underscore embedding. And then after this, we're just going to give a comma. We're going to go embedding. So the actual user search, the index name, the num of candidates, and then lastly our limit. Perfect. Make sure to close that off with our semicolon. Now again, like I said, it's going to think those are methods. We'll fix that in a moment. So this is everything we need from our actual implementation for now. What we're going to do is we're going to set up the business logic of our application. So we're going to do this in movie service. So if we pop back over here into our main, and we're going to go over to, which one's our service now? That's grand. So service is at the bottom. And we're just going to add a new class to this just called movie service. Perfect. And we can push this off to the side. Now, in movie service, we're going to need to access our repository. We're going to need to access our OpenAI service. And we're going to just create our get movie service search, or get movies semantic search, create the actual method for that. So, like I said, we're going to start with private final. And we're going to have our movie repository. We're just going to call that movie repository. We're going to have our private final OpenAI service, and we'll just call this embedder, because that's what we'll be using it for. Now we need to actually import our movie repository there. OpenAI service can be accessed. Perfect, that's fine. Now we're just going to go auto wired, and this is where we're going to use our constructor to actually set these. So public movie service. We're going to call that movie repository. Movie repository. And I'm going to save you having to watch me type OpenAI service embedder. Just copy and paste that. Perfect. And now we're just going to go this dot movie repository equals movie repository. And we'll do the same for the embedder. This dot embedder equals embedder. Perfect. That's that there. We just need to import our auto wired. There we go. Now let's check for our typos. Oh, of course we do not need this, or it will give out. There we go. And now, so that's our constructor there. So we just need to actually set up our get movie semantic search method. So again, we're doing this asynchronously. So it's going to be a mono. It's going to be a list. And it's going to be over movie. Lovely. That's that there. And get movies semantic search. A little bit of a tongue twister. And we're just going to pass in a string. So this will be what the user is actually searching for. So we can call this one plot description. And what this will return will just be our actual collection. So what the user is looking for, the list of movies. So to do this, we need to have our embedder create the embedding. Create embedding using the plot description. We're going to use flatmap many for this. That's perfect. I'm going to use the movie repository. And then, of course, find movies by vector that we have set up in there. A little bit to keep track of. And then just collection list. And that's everything we need here. Collect list. Now, we need to make a couple of imports. So first we need to import mono. we need to import list, and we need to import our movie. So there's the actual business logic of this. So this is what we're going to call when we set up our controller so we can actually interact with it as an API. So we'll pop back for that. So now we have our movie service, the business logic, we have our repository, we have the data access there, we have our data models, so our POJOs, but we need to do one more thing before we're able to take advantage of the new vector search features of MongoDB. So if we pop back to movie repository implementation, so like I said earlier, just going to give out for these. So these are the reasons we had to specify the Java version in our pom.xml file. That's because we have a couple of imports we need to make. So if I copy these two down here, so you'll see import static com.mongodb.client.model.aggregates.vectorSearch, bit of a mouthful, and then import static com.mongodb.client.model.search.searchPath field path. So these are coming from the driver from 4.11.0 onwards, and these will just allow us to actually use our MongoDB vector search capabilities. So we are missing one more thing, and that is just for our as list. So I can actually just copy this in. It's just java utils.arrays.aslist, and that will just allow us to import the pipeline there as a list. Now we need to fix this return statement here. So what this should be returning is our get movie collection. So that's just a return flux.from. That's what we've set up here earlier. Get movie collection. We're going to set up dot aggregate pipeline. And one last thing, we're returning our movie dot class. There we go. Now that's everything ready to go. We just need to actually set up our API endpoints so we can test out our application. So in order to do this, what we need to do is we need to create another package, and we're going to set up our controller. So if we go here, we're just going to go new. We're going to set up package. We'll just call this .controllers. And we're just going to call this one movie controller. Nice and straightforward. So we're just going to set up private movie service. Movie service. The constructor for this, just auto wired. And then this is just going to be public movie controller. And then we'll take in our movie service. After this, we're just going to go this dot movie service. Perfect. Equals movie service. Grand. Constructor is all set up. That's the last we need of that. We just need to import our auto-wired from Spring. And then we need to set up our map. So we're just going to set up the one endpoint. This will just be so the user can send over the description, their description. Let's say they're trying to describe movie about toys coming to life at night. They'll say movie about toys coming to life at night. Give that to the database. You'd hope it would return Toy Story. So we're going to use the @getMapping from Spring. I'm going to call it /movies /semantic search. Now this is going to be a public mono list movie. And we're just going to call this one perform semantic search. In this, we're going to have to take in the request parameters. So that's going to be the plot description. So again, we're going to use something from the Spring framework just called @request param. And we'll call that plot description as a string. And then that's just our string plot description. So if we go return movie service dot get movie semantic search, that's perfect there, and then pass in our plot description. There's going to be a couple things we need to import and fix. So this should actually be get mapping with capital M, and then we'll import that. We'll need to import our mono, our list, and our movie model. And we need to import request param. Perfect. That's it. you have everything set up. We're just going to test it so you can see how it works for yourself. I'm just going to use a simple curl statement. So here I have my terminal open, and I'm just going to paste in the command I'm going to use to test. I'll talk you through what's going on here. So we're just going to query at the port our service is running on, so 880 in my case. We're using the control that we set up earlier, and we're going to use a plot description. Now, a little bit hard to read here, just because it's URL, we're using /20 in space of our usual spaces, but I'll read it out for you. A cop from China and a cop from America save a kidnapped girl. Now, there's no movie title in there, but I think that's a fairly good description of a certain action comedy starring Chris Tucker and Jackie Chan. Now, there is one thing I'm just going to add to the end of this just to make it more readable. I'm going to use JQ. That's just a tool for when you're returning JSON, it will format it so it's not just a blob of text. Now, if we query using this, you'll see our results here. So perfect, it got everything we wanted back from the database. If we look at our top result, Rush Hour, exactly the movie I had in mind. Now, because we also set our limit to 5, there are several other movies, and you'll see we got Police Story 3, Super Cop, another movie with Jackie Chan playing a cop. That one makes sense. You'll see Fuxing. Will I try to pronounce that? I don't think I will. But either way, you'll see we got a list of movies that are similar premise that might be of interest to you, maybe if the movie or the plot of Rush Hour does particularly resonate with you. You can see how this would make sense for people who are trying to make search applications that would recommend movies based on users' interests. Also, whole host of features or a whole host of use cases outside of specific movie searches. You can think in e-commerce for searching for products. You can think there is just a wide array of applications for our vector search. So what we've done today is we've built a movie search application that you can query semantically. Now, we've used MongoDB vector search for this. MongoDB has a whole bunch of articles teaching about its different features that you can find on our developer center. Make sure to pop over there to learn more. If you want to pop over to our community as well, you can see what other people are building. You can ask questions, show off what you're building there. Also, if you liked this video, make sure to like and subscribe. Thank you.